Okay, in this video, this picture you see here is the Great Pyramid of Egypt. It has a square base, 755 feet. Everything is 755. So this is 755 as well. Okay, all around it's square 755. And we're going to compute the volume. We're going to do this using calculus, slicing this thing up. Okay, and now for this one, I want to show you something that I'm going to be using throughout chapter 8. If you go to Google Seeberger, let me make sure that you can see my thing there. Seeberger, S-E-E-B-U-R-G-E-R, calculus. Okay, Seeberger calculus. And you'll get to Paul Seeberger's homepage. Click on that, and then scroll down to here, Applets supporting Hughes Hallett's calculus. He's got some real neat stuff here, and he's got an applet supporting this problem. Well, this is 8.2, example 5. We're on 8.1. Let's close that. So we're on 8.1 example 5. There we go. So go down, click on link to applet, figure 8.11, and there you see, and it gives you a real good visual of what we're going to do here. We're going to take little slices of this thing and add all these up, and then we will have a Riemann sum, take the limit z goes to infinity, and we have an integral. Okay? And it's going to be real important here for a cross section of this one. It's going to be this triangle here, cross section straight down the middle, and you see that's what he's got over here. So, and then once we do all that, what we do is find the total volume. Okay? So let's go back here and move that back down. There we go. Okay, now that we see what we're going to do, let's flip this thing around. Here we go. Okay, so let's look at the volume of one of these slices. Volume of slice equals, this thing is a square base, so it's going to be s squared. S squared, and then right here, the width of that is going to be delta H. Okay? So let's look at, let's switch colors here. Let's go to yellow. Again, think of the cross section here. That cross section right here is a triangle. So let's look at it. And it has width 755. And then up in here we have S. Okay? And we know the total height is 410. So if we call this height H naught, we know that this height is going to be 410 minus H naught. And then we can use our similar triangles to get the S over 755 equals what, 410 minus H naught. That's my height over 410. So we get that S equals 755 times 410 minus H naught over 410. Okay? And we could do some reductions there. I'm just going to hold off. And so I get over here that my volume equals s squared which is this. It's going to be 755 squared times 410 minus h naught divided by 410 squared delta h. Okay? And so that is this one slice. And again, if we look at it and we do it for all of our slices and add them up, we have a Riemann sum, and we'll be integrating over the height. The height is what's changing there from what, 0 to 410. So my volume is going to be, let me make some room here. So my volume is going to be given by I'm going to integrate from 0 to 410, 755 squared times 410 minus h over 410 squared dh. Okay? And let's pull up the calculator and knock this out. Again, we could integrate this, but we've already tested out of that in chapter 7, so let's make sure we can use our technology here just for fun. Math, go up, fun int, there. The most important thing is that you understand what these integrals mean, now that we've already showed that we can integrate, do a few simple integrations. So my function 755 x squared times 410 minus x all divided by 410, close that parentheses, and square it, alright, comma, tell it my variable is x, and tell it we are running from 0 to 410. Let's see, it might take it a minute to do this one. Let's see, what is that? 77, let me write that down. So 77903. So this is going to be about equal to 77903. .67 416.67 cubic feet. Okay, so that's going to be, so that's going to be 77,903,416 cubic feet. And if I'm looking here at your book, they're saying that it is about 78 million cubic feet. So I think we got the right answer. So really, again, the key is here making sure that we understand what we're doing. We're taking one of these slices right here, and we're going to find its volume, and then we're going to do that all up and down the pyramid, and we're going to add them all up. And if we do this when we do this Riemann sum and we let that n go to infinity, it makes these things infinitesimally small, and you lose that error that you think you might get right there. So, and that is going to give us our final answer here anyway. It's about 78 million cubic feet is the volume of this Great Pyramid. Thank you.